Yo, what is good, y'all? Welcome back to my channel. So today we're going to be doing finding equations with no solution, one solution, or infinitely many solutions. And this has been taught very easily. And I'm going to be explaining you all the concepts thoroughly. So the first one we're going to be discussing is how do we find if equations have no solution, one solution, or infinitely many solutions. So we're going to look through that in a graph ways. So as you can see for infinitely solutions, there's this blue line that's already been marked. Now, if I'm taking my red marker and overlapping the blue line, it's an infinite solution. So if two lines are overlapping each other, and it will be mentioned in problems or anything that the lines have been over that they've been like overlined or been written over or something like that. So that's how you know if it's an infinite solution. Now, as you can tell, for one solution, one solution is when the lines are perpendicular, meaning that it's perpendicular because there's all you see in the like there's the center point, right? The center point, there's only one center point, and that's what we call the origin. And that origin represents the one solution that's there. And then the no solution is of parallel lines, because if you think of like train tracks, they're always parallel and they don't intersect, meaning that there's no intersection point. So if there is no intersection point, there's no solution. And for infinite solution, why it's overlapping? It's overlapping because no matter where it's been overlapped, all the points are going to be same on the graph, meaning there's going to be an infinite amount of points on the graph no matter how long it is or how short it is. So that's the infinite solution. And then we have the one solution with the one intersection point, and then the no solution with the parallel lines with no intersection point. Now, now I'm going to be explaining what the variables are, what A1, A2, B1, B2, C1, C2. So I'm pretty sure you all have heard of the quadratic equations, where in which an ax squared plus bx plus c equals to 0. In which a is the coefficient of x squared, b is the coefficient of x, and c is our constant numerical value. So that's the same thing with a1, b1, and c1, except what we're referring for a1 and a2 is that there are two equations for that. So one point that you guys have to remember is that whenever we're finding any equations with no solution, one solution, or infinite solutions, is that there's always going to be two equations for you to determine if there's no solution, one solution, or infinite many solutions. So that's one key point that you have to remember. So A1, B1 are both coefficients of x and y, and C1, that's our constant numerical value. And we have to make sure that when the format of no solution, one solution, or infinitely many solutions is that it's always going to be ax plus or minus by plus or minus, and then that's going to be c, which is always equals to 0. Now suppose that if there is no c, but there is an 8 over here. Suppose that there's no 0 and there's an 8, but there's no c. We're considering that there's no c. So then going back back to algebra terms, whenever we carry one side to the other by eliminating the process. So since this is minus 8, and since we have to bring it to the other side, because remember the end value is always 0, like in quadratic equations it's also 0, and in this situation the equations always have to be 0. So since this is 8, to bring it back, since this is positive, to bring it to the other side of the equation to make it a constant, that's going to be negative 8. That's your C1 and that's your C2. Otherwise, if it's a positive and there's a 0 after the equation, then C is going to be your positive numerical value. So that's what A1, B1, and C1, and A2, B2, and C2 is. A2, B2, and C2 is all the same thing. Now we're going to come to the proportions. So I'm pretty sure you guys have all heard of proportions in 6th grade, 5th grade. You might have learned all that stuff. So here, if let's say that I have an equation saying that there is 3x plus 3y minus 2 equals to 0. And then our next equation is 2x plus 2y plus 1 equals to 0. So in this case, A1 is 3 and A2 is 2. So it's going to be written as 3 over 2, which equals to 3 over 2 again, which equals to negative 2 over 1. So these are our proportions. So for infinite solutions, the proportions would all be the same. And when I mean by that they have to be all the same, I'm not talking about like the numerical values have to be the same, but like equivalent fractions, right? Or like any kind of ratio. So like in this situation I have 3 over 2 equals to 3 over 2. So in some situations it could be 3 over 2 that equals to 6 over 4, or maybe 8 over 6, all those stuff. So those are all going to be equivalent to 3 over 2. And that's what the whole point is. Because in proportions, all the fractions need to be equivalent. They're equivalent fractions. So that's 3, 2 equals to 3, 2 equals to negative 2 over 1. So if you select those, so if you see which one this fits, so 3, 2 equals to 3, 2, that's equal, but it does not equal to negative 2 over 1, which I know we're jumping straight to no solution. So this is a no solution equation right here. So these equations have no solution. So meaning they're parallel lines, and this is the best way using the proportions to find out, and it's also the easiest way to find out if an equation has infinite solution, one solution, or no solution. So for infinite solutions, you have to make sure all three fractions are equivalent or they're equal. For one solution, what the case normally is that if we have the first equation, the first fraction, it's 3 over 2, but our next fraction, which is b1 over b2, say that b1 over b2 is negative 2 over 1. So 3 over 2 does not equal to negative 2 over 1. So this is going to be an example of one solution. Now there's also some situations in which a1 over a2 does not equals to b1 over b2, that does not equals to c1 over c2, which kind of makes sense because if there's only if the first two fractions aren't even equal, the next two fractions might not be equal, but there are some cases where the next two fractions are equal and the first two fractions aren't. So those are going to be the one solution problems. Now the no solution one, which we have just now covered, which is if first two fractions are equal and the next two fractions are not equal. Now in this one, there are no if or buts or anything like that. It's just straight up forward, cut straight to the point like that. A1 over A2 equals to B1 over B2. That does not equal to C1 over C2. Straight up, and no buts, no ifs. Same thing for infinite, they're all equal straight up, no buts, no ifs. But for one solution, you have a condition over there. Now I'm going to be explaining you one of the most important conditions when solving these equations. So whenever we're finding an equation that has either one solution, no solution, or infinitely many solutions, we need to check if there are any conditions, like um, there aren't any rational numbers, because normally when you look for equations and you substitute the values in, there's always going to be some kind of value in there, but there's always going to be conditions to say that, to state that, okay, no, there's a condition and you have to follow those conditions. Otherwise, if there aren't any conditions, I like to say, don't beat the system. And basically what that means is that don't wonder there are and that there's no more solutions to the equation. Just follow the conditions or don't beat the system. Basically what I mean by don't beat the system is that don't think hardly any or push yourself to think that, okay, there's going to be there these are the other solutions, these are the other solutions. Don't even worry about that. Nobody cares. That nobody cares if you're doing the no solution, one solution, or infinitely many solutions. So when you're going to do those, you have to make sure you're following the conditions. And sometimes it might say that, okay, there are no rational numbers included, or there's no integers, or if there's no conditions that have been stated, just follow the infinite solution, no solution, or one solution rule. It's just as simple as that. So again, like I said, please don't beat the system. Now we're going to do 4 practice problems. I'm pretty sure you might have already seen them, but we're going to go through it. So the first one is to check. We're going to just write A1 over A2 equals to B2 over B1 over B2 equals to C1 over C2. So let's check. So since there is no coefficient of x, since x is just single, we're going to write 1. So this is for our first equation. For our next equation, the coefficient is 3. So that's 1 by 3. And you also have to consider negatives and positives in this. So in this, b value is -3 and this is -9. So this is -3 over -9. Which again, you can tell that this is equivalent because you can cross out the negatives, because negative divided by negative turns into a positive. So you can just cross those out. So that's just 1 by 3 equals to 3 by 9 over -3 by -2. -3 over -2, which again, you can cross out the negative symbols. So then that's basically, it's just 1 by 3 that equals to 3 by 9 that does not equal to 3 by 2. And if you remember, you can go back to this video and go back and see that this fits the no solution. So this first one is a no solution equation statement, or condition, we could say. Now let's verify the second one. And what I like about the second one is that it has no C value, which I discussed in the beginning of the video too. So let's see it. So then that's just 2x plus y And remember, since the end of the equation always has to be a zero, this is we turn it to the overside to the other side, which is -5, which equals to 0. And then we do the same thing. 3x plus 2y is -8, which equals to 0. Now we can do our regular proportions and see if they fit. So this is 2 over 3 equals to 1 over 2. And you already know that this is a 1 solution, but we're still going to check. And this is -5 over -8. So obviously none of these match. So if none of them match, then it's a no solution. Sorry, one solution. So this is a one solution situation. Now I'm going to leave these two problems in the description box for you guys to answer, and I will also leave the answer in the description box. Just please make sure you don't cheat and just solve those first two equations, and then you see the answers at the bottom. Thank you, and make sure you guys like and subscribe if you like this video, and I'll see you in the next one. Bye.